Hello folks, welcome to my channel. So this is the part 3 of the asynchronous programming. In the previous part, what we saw, we launch several tasks in a synchronous way. In this video, what we will do, we will try to launch all these tasks parallelly or maybe concurrently through executor services. So let's switch to the IntelliJ. So now this is our previous example, and what we have done, we have these callables, we have these 5 callables, we have the list, we create a list of all those callables, and then one by one we execute it. Line number 45, we are executing it, and after all the tasks have been executed one by one, what we are doing, we are just getting the minimum of all the values which we received from the servers and find the minimum value, and then we just open the optional with the help of or else throw, and then we have wrapped this whole operation inside the start instant and the end instant. And why we have done, just to get what time it took basically to execute the operation from 48 line number to 51. And this is our simple example, and what we will do, we will again run this and see what it is giving us as a result. It's giving us 2309. We will run this again. We get 2385. We will again run this, and this time we got somewhere around 2440. So roughly we are getting somewhere around 2350 milliseconds to 2400 milliseconds. This is what we are getting as a result. So what we will do, we will just copy this whole thing and we'll try to do asynchronously or parallelly, I would say. So I'm just pasting this here. I would just say run concurrently now, and of course the callables are going to be the same. Let's have this task list as well. What I really need to delete it, I need to delete this things, and just comment this out before we write the code. We will just open these lines again. So now what I need to do, I need to run this task parallelly, and to do that, what we will do, we will create an executor of new fixed thread pool. So we have 5 tasks needs to be completed. Let's have this as 6. One is a sparing thread only. Great. Now what I need to do, I have this task list. I will just loop over them. And then what I need to do, I just need to submit all my tasks to my executor service. Let's do this. Submit task. And what it will return me, it will of course return me some kind of a future. And I really need to collect this future. How will I collect this future? Let me have a list of futures. And what I could do right now is just add all my this to this list. So what I'm doing here, I'm submitting my task and I'm getting the future, and I'm collecting all the future in my array list. Now what I have to do, I have to just fetch the result of all these futures. So that is quite simple. Go quotation future from futures. And what I need to do, I just need to call the blocking call. Of course this is get, and of course this is throwing some exception. Let's throw this exception, and our code is compiling fine. And I really need to fetch the result. So what it is returning to me, it's returning to me some kind of a quotation, and I need to collect all my quotation now. So again I could have my quotations new array list, and it has to be of quotation. Nice and great. Now I just need to add, rather than taking this, what I could do, quotations dot add. So I have now the results of all my quotations in my quotation list. Now it has become a very simple, I would say, stream question only. I will just take this command X, and I will just take this just above this line, because I need to start my operation needs to take from what time it took from line number 55. So I have my quotations. I need to open a stream on it, and I open to have a min by operation, and it's very simple. Compare it to the comparing quotation column get value, opening the optional now or else throw, and this I will collect this in some kind of a best quotation. Quite great. And now I could uncomment this line. Let me reiterate what we have done. We have the same callables. We have 5 callables task which needs to be executed. What we have done, we have created a pool of threads, 6 pool of threads we have created at line number 50. Then we have submitted all our tasks to our executor services, collected all the features which were written immediately after submitting the task in some kind of a list of features. Then what we have done, we are waiting for the task to get completed. So this line is a blocking call, but still our tasks are running in parallel. The main thread is waiting, and after we have received all the results in our quotations list, it's then it just become a simple stream question. We stream on it, we find the minimum, and we have opened the optional here, and then we have written this line number 67, the operation has been completed, and then from 68 to 71 we have just printed it out. And now here I need to call run concurrently to see our results, and let's see how much time it took. It has took 494 millisecond this time. I am again running this program. It took 496 milliseconds this time. Again running this 502 milliseconds. Our JVM is not being shut down. Why so? Let me just fix this problem as well. I just need to shut this down. So let's run this again. Nearly is taking 503 seconds, and if we run our synchronous code as well, and let's see the results. The synchronous code was taking somewhere around 2300 milliseconds, and it is taking 500 milliseconds when we run concurrently. So clearly we have a difference of more or less 5 times less the executive services are taking when we are running our task parallelly. We could run once more time, and we could clearly see the factor is always very close to 4.5 to 5 times less. So this is quite nice. We are not done yet. We will see how we could achieve the same kind of a problem with the help of completion stage APIs in the next video. Till then, bye bye. Please subscribe to my channel, like this video, share this video, and we will have a lot of fun in this asynchronous programming.